look at example 2. So we have concerns about global warming. There's some data here about the carbon dioxide levels and the temperatures. And it says use a 0.05 significance level to test if there's a linear correlation between temperature and carbon dioxide levels. So what am I going to do?
HO and H1.
HO and H1, which for linear correlation questions will always be
Point.
Zero.
rho equals 0,
Rho does not.
rho not equal 0. That's what he meant. You were thinking, what if we don't have significance level? I was with you. I like to write these words next to it. You do not have to write these words, but it helps to remember which one is which so that you'll know what your conclusion tells you. No correlation, yes, there's a correlation. We were given alpha equals 0.05. Then what?
And then you do the line to that.
Yeah, the linear regression t-test, we have to put all the data into our calculators. See if I can get my computer to unfreeze. I can, what the heck? I need to trust you guys to type those in and do the linear regression t-test. Okay, most of you got there? Did you get a test statistic? Of an R, 0.892? We agree with Evelyn's R? By the way, this test will give you a T, which looks like T is your test statistic. It's actually running a version of the t-test, a different t-test than what we've seen before. But when we're talking about correlation, the R is our test statistic. You could also do the p-value, which your calculator gave you. Which was? 3 zeros? What was the last number? 0005? Yep. Yes.
For that, could we put 0 plus? And then just include like the scientific value?
Usually we only do 0 plus if it's more than 4 decimal places, like if it didn't start till the 5th one. So if you can fit, because usually they ask you to round your p-value to 4 places, so in which case you'd have to round it to 0.005.
Okay.
I usually only use 0 plus when the first 4 round to 0.
Okay, yeah, because on mine it just says 5.21 something, and then E negative.
Yeah, so E negative 4 means you can still fit it in 4 decimal places. And so what's my decision? Reject H0. So my conclusion,
There's not a correlation between temperatures.
there's not?
Yeah.
No.
You want to guess again, Brian, before they all yell at you?
Reject HO. There is a correlation.
Thank you. Want to give you a chance to save yourself before they all started yelling. They were getting ready. We all agree that there's evidence of a correlation? Because we rejected H0, we rejected this. So we have evidence of a correlation? A lot of you asking questions of each other, which is good. I'm pausing to see if anybody has a question for me. It's the same thing, those darn conclusions. Which is why I like to write this out. By writing this up here, when you reject that there's no correlation, then the only other possibility is there is a correlation. Find the regression line is the first thing it asks for,
The best prediction.
and then make the best prediction. So where am I getting the regression line? Y equals A plus BX off of our calculator. And when you're doing these online, the MyStatLab will tell you where to round if they need to be rounded. A and B aren't always nice perfect numbers. What is A? You guys have your calculator screen in front of you still, where you got this one?
10.48.
10.48, so we'll round to 2 decimal places. Was it rounded 48?
Yeah.
Plus
0.011.
0.11?
Yeah.
This is the A and the B from your calculator? So the first part of this question was find the regression line, there it is. I'm sorry? We just put the A in the front and the B next to the X. That's all you have to do to get there. I mean, there's no work to do once you do the linear regression t-test. So that's the creation of the line, and then the next part is to make a prediction for when the carbon dioxide is 320.
We always have to include the
I don't care if you put the hat or not.
Yeah, oh,
But when you're doing it online, it'll ask you for y hat equals, and so I just want to make sure that that's the prediction line that they're using.
Okay.
What am I going to do to make the prediction?
Plug it in and
Put the 320 in for my x. 10.48 plus 0.11 times 320. Yes?
use the decimal on the second number.
Oh, thank you. I got creative with my decimal. Give me a different answer for sure. What do we get? 14? Exactly? Does that make sense according to this data? Does 14 seem reasonable?
Yes.
Yes, why?
Can you split 14 over 1?
Because what?
Split 14 over 1. Make 1.
No, but according to this data here, how does it fit this data?
Temperatures have 14.
Yeah, the temperatures that are listed are all like 13.9, 14, whatever. They're all in the 13, 14-ish range. So it makes sense that my prediction would be somewhere in there. If I had accidentally done what I did with the decimal, I would have had like a 140. And that wouldn't have made sense. Like, wait, that can't be 140. That's not anywhere near this data. So you want to look at your data and see if your prediction makes sense. We good? Yes?
That's the best way to write the answers is the y hat for the line regression and then the y hat underneath it for the prediction. You don't have to write like a sentence or anything.
The only sentence that we needed was to talk about whether there was or wasn't a correlation. What's interesting is the question that I just asked on page 149 for 10.2, you'll quite often just be asked the make a prediction question, which really means, oh wait, first you have to go do a test and see if there's a correlation and get that line, and now you can make the prediction. So which is why I'm doing the 2 sections together. Because in the one section it's just, is there a correlation, yes or no? And the second section is, can you make a prediction? And so, but they're totally tied together, which is what we're doing. Example 3 on page 145, we now have brain sizes and IQ scores. Brain sizes and IQ scores, so they measured how big someone's brain is and they measured their IQ score. And we're looking to see if there's evidence to say there's a linear correlation between brain size and IQ score. It doesn't really say test the claim, right, but it implies that.
We use 0.05, right?
Yes, so this is an example where they didn't give us a significance level. So they start doing that in chapter 10. Alpha equals 0.05, but they don't give us one. That's the most common one. What are my claims?
P equals 0. Or
It's not a P, it's a rho. It only looks like a P. Rho equals 0 and rho not equals 0. If it were a P, it'd be a proportion. It'd be a one-prop B test, something totally different.
it's like italics P.
Okay, yeah, italics P, I'll give you that. And equals 0 means there's no correlation. And not equal to 0 means there is a correlation. And then you're going to carefully type that all into your calculators. So the calculators have quieted down. Does that mean we have R? What is it? Again?
0.263.
0.263? Agreed? Is that how big or a small r? It's pretty small. It's closer to 0 than it is to 1. It's a pretty small value of r. What was your p-value? 409? Clearly not less than alpha. Right, that's definitely greater than alpha. So either case tells you to fail to reject H0. The first one we've seen where we failed to reject? What's my conclusion? Well, what does my evidence tell me about correlation or not, though? That's all we really need to say. Insufficient evidence of a correlation. So either you have evidence of a correlation or you don't have evidence of a correlation. That's really all your conclusions are in this case. Even though my R was not 0, it's a little bit of evidence, but it's not enough far away, it's not far enough away from 0 to say there is a correlation. You could also write no evidence of a correlation. Are we okay with the conclusion? There's a follow-up question. What's the follow-up question say? Oh, there's a typo in it. Does it appear that people with a larger brain are more intelligent? No? Why not? Because there's no correlation. They're saying there's no relationship between brain size and your IQ score. If there's no relationship, we can't say bigger is better or smaller is better or any of that. So the follow-up is no. We don't have a relationship between brain size and IQ. Find the regression line. How do I do that? Y equals A plus BX, where the A and the B are on the same screen that gave you your R and your p-value? Yes?
I thought we don't plug it in because there's no correlation.
We don't, but it asked for the line,
Oh, okay.
so you're a step ahead of me. If it asks for the line, we have to write the line. Y equals A plus BX. So off of our calculator, we get 12.45?
51.45.
I couldn't hear you, sorry. Start over.
51.45.
51.45 plus
0.05.
0.05x. We agree with Kirsty's numbers? The A and the B off of our calculator screen? So this is the regression line that they asked us for. Here's where you have to actually think for a moment. Every once in a while I ask you to do that. We just found that there's no evidence of a correlation. Which means that my graph looks like what?
It's all over the
It's kind of all over the place. There might be a slight hint of an upswing because of our little bit of an R here. There might be a little bit of a positive if you kind of look back, but not very much. And so this is like the best line they could draw through that data. So imagine, I'm going to do a rough sketch of it, I don't know that this is it. Imagine that my data looks like that. And so then we got this line, and the line looks like this. close to much there. I mean, we could put a line through there, but it's not going to be the best prediction because we don't really have a correlation. So just because your calculator can find you this line, doesn't mean it's a good line to use. It'd be if you walk in for a new job and you said, hey, how much are you gonna pay me? And the boss says, that depends. Can you tell me how many Legos you have at your house? I'm gonna plug it in this formula. And then I'll tell you how much you're gonna get paid. And the Legos have nothing to do with your salary, right? So just because I might be able to come up with an equation that relates Legos and salary, I don't think that's how you want them to decide. Unless maybe you have a lot of Legos, it might work to your advantage. But the rest of us, maybe not, because there's no relationship there. So just because you can come up with an equation doesn't mean it's any good. So that's what Hector was asking a minute ago. He thought we weren't going to use it. We're not. We found it, but it's no good. No good. Because we have no correlation. I cannot tell you enough the number of people, it's an R, I don't know why it's a weird R, who will find the line and plug in X every time. That is not how we make the prediction. I need you to flip back over to the bottom of 148 to remind you what I said earlier.
So we're not even gonna bother plugging that number in because
We're not going to even bother plugging in that number into here. That's like plugging the Legos in to find out your salary. It's not going to help. Back on the bottom of 148, it said, if there is a correlation, we're going to plug into that line. If there's no linear correlation, what's it say? The best prediction is the mean value of y. So the best prediction in this case is y bar, the mean of the y's. Ooh, how am I going to find it?
You do one bar stack.
I could do one bar stacks. With which list?
L1.
L1 is the x's. We gotta do L2, right? Because the y's were in L2. So some options are to do one bar stats with L2. That's one option. What's another way that we could find y bar?
Can't you just do it on the list?
Say that again?
No.
Oh, okay. I like you thinking out loud though. That's good. How did you find averages before you met me?
Can't you add them up and just divide?
Yeah, we could add up all the y's and divide by how many we have. Add all y's. Then divide by, how many do we have? Anybody count?
12.
And divide by 12, because there's 12 of them. So these are options. Option 1. Option 2. You have option 3 that you haven't seen before. It's not really much different. You could do 2 bar stacks. L1 and L2. And it'll tell you what's happening with your x's and with your y's, and you still want to take the y bar off of there. Any of those, I don't care which way you do it. You don't even have to write down how you got it. You just need to tell me you're finding y bar. Yes, ma'am.
Why do we have a triangle?
Because we're trying to make a prediction.
Okay, and then do we do that for both if there's a correlation, if there's no correlation?
No, so go back and read page 148 again when you have a chance. If there's a correlation, we're going to follow that line because the line tells me there's a relationship. If there's no correlation, then the best thing we can do is take the average. So if you walk in for a new job and you don't want me to make your salary based on how many Legos you have at home, I'm just going to take the average salary and start you there because that makes more sense. So the mean is when you don't have a correlation. Any question about the 3 ways of finding your y bar? I'm hoping you found it at least one of these 3 ways. What did we get?
100.08.
100.08? We agree with her? Someone who's not getting that, I need to know so I can help you do it, whichever method you're doing. I just tend to do Kirsty's first idea, 1 bar stats with L2. It's the quickest, easiest, it's more familiar, something we've seen before. The tricky part about this is it calls it X bar. right? When you do one of our stats, it calls it X bar, but since you know you were looking at your Y list, that's really your Y bar. So the question was, find the best predicted IQ score for this person whose brain is 1,020 cubic centimeters. I didn't even use that 1,020 at all. Why not?
Because there's no correlation.
Because there's no correlation, there's no relationship. It's like me using your Legos to figure out your salary. I don't need to know how many Legos you have. And so in this case, we don't care about the size of your brain. We're just going to assume that you have the average brain, the average IQ score. Because your brain size isn't related to it in any way. So this is the best predicted score.